All right, on this problem here, we're going to talk about how to get a remainder when you're dividing an expression by an expression that has an x plus or minus a number. In this case, we can use synthetic division or the remainder theorem to get the answer. We'll start with the synthetic division process. What we're dividing by, we're going to take this number and we're going to switch the signs. I put it in a little box. Now I want to look for any missing terms. So this is a fifth power, a third power, a squared term, a first power, and a constant term at the end. You might notice this particular example is missing an x to the fourth power. So we're going to put a 0x to the fourth in the middle. And as such, when we write our coefficients, that's a 1. We put a 1, 0, -3, 2, -4, and 5. Now to get that remainder, we have to go through the process of synthetic division. We have our opposite of what we're dividing by, all our coefficients, including the 0, drop down the first number, put it underneath the line, multiply it by this number in the box, and that's going to give you -1. Add down, 0 plus -1 is -1. Again, multiply the -1 times the number out here, so -1 times -1 is +1. -3 plus 1 is -2. -2 times -1 is +2. 2 plus 2 is 4. 4 times -1 is -4. -4 plus -4 is -8. -8 times -1 is +8. And finally, 5 plus 8 is 13. That's your remainder at the end. So my remainder in this case is 13. As a reminder, you can also get the remainder using the remainder theorem, which states that you can plug into the function this -1 for all your x values. So if my original expression was x to the fifth minus 3x to the third plus 2x squared minus 4x plus 5, then wherever you see an x, you can plug in a -1. Use parentheses when you're plugging in always. And then plug that right into Desmos. The good thing about Desmos is you don't need to put in the 0. And there's your 13.